Ladies and gentlemen, please welcome our next speaker, Mario Fahlandt, presenting the topic, Cloud Native Security, a new paradigm for a new world.
So, hi everyone. How was lunch? That's the right answer. So, now something light, security. So that the easy talk after lunch. I try to make it as entertaining as possible. The first question is, who am I? Hi, I'm Mario. I live in northern Bavaria in Germany. I work for a company called Kubernetes, and I'm also part of the Kubernetes project itself. There I'm the tech lead for communications, and I'm also part of the last week's in Kubernetes development newsletter. Hard word, but it's a website. You can check it out. There you can basically see which pull requests got into KKP, to Kubernetes, and so on and so on. I'm also a Google developer expert for cloud, and I'm an ARM ambassador. Quickly, what Kubernetes does. Kubernetes has 3 open core products. We run Kubernetes inside of Kubernetes. We have a multi-tenant load balancer. We have Kubernetes lifecycle management tool, and we do consulting. So, who of you is part of a security team? 4.5. Who of you is a developer? That's more. And who of you is an operations person that need to run stuff in cloud or on-prem? Okay, so we have a mixed crowd. The reason why I'm asking is, you all don't talk to each other most of the time. Because let's go back in history, or like 10 years ago, 15 years ago, and we have like security team, development team, and the idiot that needs to run the stuff. Usually this was me. And the security team came up with great concepts. There are 3 great concepts that we can talk about. And the first one is, we build parametric-centric defenses. So we build a stone wall out of our around our infrastructure, then it's safe because nothing can get inside, as we know. We have a manual process. If something goes bad, then someone needs to take care of this, and this will then be discussed in a meeting, and then we slowly move forward. And as I told you, the silo approach. So development, I don't care where it runs on my PC. Security, like there was some government letter that said you need to do stuff like this way and you can't move away from this, and that's how we do security, and you need to do this, and otherwise we don't allow it to you. And the ops guy is like, I have servers, I don't care. So let's start with parameter security. Basically, parametric security is exactly this. I have my wall around my world, and everything is fine if I'm inside the world. This also was, the CIA thought also the same way in, I think, 2011. And then someone dropped a USB stick on the parking lot. And this USB stick was picked up by an employee. And what is the best thing to do with an USB stick that you find in the parking lot in front of your company? Yes, you plug it into a PC inside of the network and see what's on the USB stick. This was a bad idea because then you opened basically the backdoor. So if we go back to our castle analogy, it's like, yeah, we dig a tunnel underneath the wall and then just got out in the inside world. So the problem is that we all know best movie in the world, Hackers, was released somewhere in 1994 or something like this. Amazing movie. So we know hackers are skateboarding and going to telephone booths and connecting to telephone booths. No, they are not. Hacking has changed, of course, because they are adapt as well. And hacking is targeting every one of you. I mean, you see this basically daily. Like, you get an email. In the email it said like, hey, I'm George. I'm the new colleague from the new office in yada, yada, yada. Can you please send me this information? Can you please send me that information? So we have the problem that the angle where we are getting attacked is basically the people. So we attack layer 8 of our world, and they try to get into your system by people engineering, so social engineering. This is the way how the most attacks are being carried out, because brute force attacks, there are services for this. I can just route them away. But the problem is every employee. So we have different layers where our security needs to be. So we need to have like a layer that protects the employees. And this is usually done by the thing that every one of you really like to do when in your company, when you got onboarded and you have to do it every year, is the answer these questions. What would you do? Don't leave your work laptop unchecked, and so on. And yeah, then you have a meetup in your company, and the pizza delivery guy enters the building because he's bringing pizza for the meetup at 10 p.m. and people don't care, and the pizza guy is just walking through your offices, and yeah, who's checking this person? Probably no one. Also, we have the fancy things like you get a key card and you get a key card to get into the system, but those key cards can be lost and replicated and cracked, so people can get in this world. We have network security. I mean, when we have already neglected 2 layers of our security. So when we go to network security, it's like, yeah, we have everything protected to the outside world, but not inside. So we have the problem that inside I have big networks and I can just do whatever I want. And the next step that I basically need to do is I need to take care about endpoint security. I need to take care about applications. And the deeper I get, the more critical data I can basically grab. So this is our old world thing. And the next thing that we have is manual processes. Who knows what a CVE is? That's not much. So security is a manual process. So something, a security risk was found, needs to be fixed. So you need to fix it, and you need to fix the problems that occur there. And so we need to patch our systems. We need to update our Docker images. We need to reschedule our containers that they are placed everywhere. And this takes time and effort, and this is usually manual, and this is bad. So when it comes to CVEs, CVEs are common vulnerability and exposure issues. So it's a glossary that defines basically vulnerabilities in software. Currently, we have 233,151, and I updated this slide half an hour ago, and I hope that this number is accurate now, because it's growing like really, really fast. So when we have a look in the history, 26,000 CVEs were filled last year, which is 5% more than the year before, which is 24% more than we had in 2021. And when we look at the graph, they exploded by a lot. And the problem that we have, and this is basically a really, really, really new information for you, this happened 24 hours ago. So 24 hours ago, in February, the kernel.org, so the organization for the Linux kernel, was added as a numbering authority. So the kernel.org can now file CVEs. So they can create a new CVE number, create a new CVE based on issues. The problem is that they are now inflating the system. So they opened up 700 CVEs in the last 7 days, and they did it retroactive. So every bug fix that came into the Linux kernel in the last years is now declared as a CVE, which is utterly nonsense, because sometimes it's all just a typo that was fixed or something like this. And this is a real interesting discussion, because usually everyone in security says like, okay, a CVE is released and I need to check my software if I'm affected by it. For example, there was a CVE regarding that affected container D. Container D, everyone knows what container D is? Container D is the runtime, is a container runtime that is the current default for Kubernetes. It's basically how containers are run in Kubernetes. And the CVEs basically said that, yeah, there was a bug that could, that's always the important thing, that could affect and could be a security issue in your system. So we basically said that, okay, we need to fix this. How did the fix work? The Kubernetes containerd contributors fixed the issue. Then 8 hours later, the bug fix was released for the Kubernetes repository. And 7 days later, the flat car image was updated, in between Ubuntu updated, and so on and so on. So when a CVE is published and released, everyone is jumping on the oh fuck train, and we need to fix the stuff. And this is basically what they did. And the problem now that we are inflating the system, we are basically creating the main problem that I can't trust CVEs anymore, because I don't know if I need to fix this or if I have already fixed it like three years ago. And this is a real problem, because we are losing our way of identifying problems. So, and the last point that we had in the old world thing is the silo approach. I already talked about this. In the past, it was, it's not the past, it's the current, still the current. We have container, we have our security teams, we have our ops teams, we have our development teams. Even development teams beneath each other don't talk with each other because they don't care. I don't care what front end does because I'm back end, and so on and so on. And this silo approach limits the way how we can implement security, because security cannot be put on top of each of the steps. Security needs to be throughout the system. We fixed this a couple of years ago, somewhat, because we said, like, use Docker, use containers, because containers will fix everything. It's we make your computer shippable. The problem with this is that they still rely on the underlying platform. They still rely on the underlying systems, and not every environment is the same environment. So that's a problem. When I started, and this is not so long ago, hopefully, so 2004, 2005, every server that we set up, and this is probably you heard many times again, was a pet, because my database server had a name. I identified my database server. And in the cloud native world, we move away from naming things, because we don't treat them anymore as pets, because we don't care if they die. The goal is, we want to have systems that can go away and that I don't need to care about anymore. And we will get to this point later in time again. So another example that we had or another example that old security teams usually have is ports. Everyone knows ports, right? What is running on port 2020? Exactly, SSH. What is port 25? SMTP, right? Everyone knows this. This is a fact. So I know a port is something where I can rely on. The problem is, there's, for example, if I want to expose a service via node ports in Kubernetes, we have a port range that we open. The port range is 30,000 to 32,000 something. And the security team, and this is not made up, I had 3 different companies that came to me and said, like, we can't open 2,000 ports. That's a security risk. No, it's not. It's not. It's like, we don't use those ports. These are the Kubernetes default ports, and you can reduce them. So they asked us, okay, can we reduce it to 200 open ports? Okay, we reduce it to 200 open ports, 30,000 to 30,199. Guess what? They deployed 205 services. What was not available? 5 services, because no ports anymore. Because they don't understand that the concept in the new world is ports are still a part. We still need ports, but they are not like a specific thing. And I don't know if anyone saw the talk of Abdel. It's like, Abdel showed an application that randomly created a port, or used random created port to run the application because they don't care. Ports are ephemeral. It's not. They get random assignment, and I don't need to have 80 as a web server because it doesn't matter anymore. Microservices and APIs talk to each other inside of the cluster based on their inner cluster IPs, and they talk to each other based on the mapping inside of the cluster. So the port is just like another identification number, but it's not a fixed thing where I can say like this application goes to this server, so I can open up this port there. This doesn't make sense anymore, because the problem that we have is, even if I block a port or if I have an open port, I can't guarantee that not a security issue is coming in there. So basically what we move to is a zero trust. We don't care anymore where what is the port where it's running. We care who wants to access what. So we need to identify all of the different parts. Also, another thing is everything needs to be encrypted. So we need any traffic that goes anywhere need to be encrypted. So what we do is we have, in the cloud native world, we have identity access management, which means that we need to identify and manage all of the things that go on. We need to have a behavior analyst, which means that if we have like a service that constantly talks to another service, I know what is going on there. I know the behavior of this, and it's I can identify a security risk by seeing what is, if there's a change in the traffic patterns, or if there's a strange behavior in it. So this is something that we need to implement for increasing security. Also, networks. In the past, we had like this huge networks, but the problem is you don't need a huge network. I know who needs to talk to whom. For example, if I have Kubernetes nodes and I put them, a Kubernetes node don't need to talk to the other nodes. They only need to talk to their control plane, which means that we only need to have what is called connectivity, for example, in Kubernetes, which connects the worker node to the control plane. And that's the only thing. That's a tunnel, one-to-one connection, and they don't know which other servers are in the network because they don't care. It's not their job to care or to see anything else in the network. So what we do is basically we take every environment gets its own network separation based on its criticality. So we have more smaller networks that are just there to host nodes, and everything else is managed inside of clusters with network network policies and clusters, and so on and so on and so on. Also, we have central gateways where traffic needs to go through, which is API gateways, where we can say like, I can say where do we need to go where, so that we can basically see that what's the goal where we want to go. So it's all, we still have ports, but they are not as important anymore. And all of this come together and now I'm boring you basically. This is all called DevOps. Has been called many things. DevOps is around since forever, but the idea is basically that we want to have a world where each and everyone talks to each other. It's not that this is not a job role, because if anyone says to you that DevOps is a job, that's a lie, because this is a concept of different people in a team that are working together. So I have my developers and my my ops people working together in a constant stream, that everything is always repeating each other. And this is basically how DevOps was born. And this was 2003, so this is old news. The next thing that we had is clusters are becoming cattle, which means that clusters are no longer, as we had with our VMs back then and our database servers, we don't care about clusters anymore, because we can easily exchange clusters and they can die, and we need to move stuff from one to each other. So how do we ensure this whole thing? So how we make sure that this is actually working? there are three constants that we need to adopt in the cloud native world. So we always need to have automation. Everything that I do needs to be automated in any way. Why? Because I can leave the company next week, and I was the only one that did this. Who will my computer, my bash history? Good luck getting this. So this needs to be anywhere in any in a stable environment that I can change. Immutability means I have my whole infrastructure in a repository, and no one is touching a server anymore. Why? Because you can't track what has changed inside of a manual change. So this means that changes to your infrastructure are pull requests, because people can review it, people can double check it, and you can revert it, and you have a history. You can know why something was changed. And what we also need is we need every time 24/7, we need to observe how our infrastructure is behaving. The good thing is observability can also be done with automation. So that's why everything basically ties in together. This brings us to a next ugly buzzword that everyone probably heard. It's shift left. What is shift left? Shift left means we move security more left in those DevOps thingy thing. Why? So that we have different topics in the, or that we have different parts in our environment where we can basically implement different security matters. Who knows, or who is using SAST in their company? 3 people, 4 people, 5 people. That's good. Who is using Dust? 2. That's not so much. So to explain a little bit what SAST and Dust means, it's basically SAST is a white box testing. White box testing means I actively test my code, or my code base is being actively tested because the program knows the code base and can look into it and see like, okay, this package has a vulnerability, this package needs to be patched, and so on and so on. So this is basically like we implement security with closing CV or patching infected versions early on. Dust is a little bit more complicated because Dust is a black box testing. Dust means that we need to test, or we test end to end. So we see if the application or our application stack is behaving normal, and if there's any security risk that goes into this. This makes scanning, of course, way more complicated, but this is on the development level. So this is something where the developers need to take care of, and not the ops people, because the ops people don't care what code is inside of their container because they don't know in the worst case. I don't know what if Node.js needs a package update or not. Also, we talked about containers. People, you know, the first line in the container is usually from Docker blah blub. The problem is from blah blub means I trust that the image that I have above is patched, and I have like all of the stuff is updated, and someone cared. Guess what? No, nobody cares. There are tools that automate it. I mean, you can have security scanners that check for vulnerabilities and scan your container images, but this also needs to be done. So every time you publish something or you pack something in a container, this needs to be checked. And the last thing that we have is compliance. We are in Europe, and in Europe it's always great because we get a lot of new laws and new guidelines that we need to apply. And those compliance scans, if anything critical is in there, need to basically go into this as well. So this is something that is really critical, that people are taking care of compliance, like GDPR, non-GDPR violations for data handling, and so on and so on. So this is also part of your security process, because no one of you wants to be the person that said like, yeah, we accidentally leaked 2 million customer data. It happens. So what's the goal to build the architecture around it? So basically what we aim is, we stated that we had all of the security tool sets and we built our infrastructure. So the goal that we want to achieve is basically, we don't trust anyone. I don't trust you. I don't trust my my employer. I don't trust the guy that built an open source package. I don't trust any Docker image. So what we and foremost is, I don't trust my application itself, because we are all living in this microservice world, and microservices are now going back to monoliths because AWS published a paper that they moved to monoliths, and now everything is great again in monoliths. We will see about this, but the problem is, I need to make sure that only the specific parts of my application stack can talk to the very application that it needs to talk to. For example, a friend of mine runs a company, and they accidentally published to the production database instead of the development database. So they did the migration on the production, not on the development. That's not so great. And this could have been fixed if you would say, like, my upgrading or my migration service can only talk to my development if I deploy into development and not accidentally to the database. It would have been even better if you just separate the whole environment, but that's another topic. That's basically the same for microsegmentation. So if anything goes to nuts, then it's only a small part that is exploding. So our new parameter, when we go back to our first slide with the castle, is identity. So I basically go ahead and say, like, everything needs to authenticate against each other, even if I'm inside of a cluster. So we need to have a strong parameter with identification. We have to, I need always to implement myself that I go ahead and only talk to a service where I know that I'm allowed to talk to. Kubernetes. Let's go now into the whole platform thing. So basically, in Kubernetes, we have containers, and containers, as I said, need to be scanned. So there are a couple of tools as we go back to automation, because I don't want to do this by myself, that does this for you. The problem with this is they are commercial tools, but I'm not a fan of commercial tools because I do mostly open source. That's the reason why I use open source tools. So some of those tools basically go ahead and give you options to automatically run inside of your build process to find vulnerabilities, to figure out, they implement into your registries that you can just run inside of your registries in your automated deployment process, and that take care of this. Another point that I didn't add there is, when you run in Kubernetes clusters, how old is your longest running pod? Exactly, hundreds of days. What's the problem when a pod is 100 days old? Exactly, and the problem is that we have inside of this image, there are vulnerabilities that are more than 100 days old. Maybe the image is already updated because our system already took care of it, but the pod is not restarted in the Kubernetes cluster. So this is also, I saw it a lot. They had everything in place. They updated everything, but they didn't update their life cycle inside of the cluster. And because they said, like, yeah, but then the service is breaking because we can't restart this pod. That's not how Kubernetes works. Kubernetes, the idea is everything, and then we go back to Kettle, everything can die at any given point in time because it doesn't matter, because we have fallback mechanisms to reconcile this. That's the idea behind Kubernetes. If something fails, even down to a node level, another node can take over. And we are even at the point with cluster autoscaler and so on, that we can just provide new nodes where the stuff is going on top of this. So inside of the Kubernetes cluster, we also need to double check everything. We also need to have a check that helps us to find those things. And for example, there are tools with, for example, file codes that tells you and says like, hey, this container runs more than 30 days. Restart. Even Kyverno has a function that basically warns you. Kyverno, everyone knows? Okay, Kyverno is a policy management tool for Kubernetes. It's also open source, of course. And you can basically implement policies to say like, hey, you can only pull from this registry. Only traffic can go from A to B. I can only use images that are listed in this specific thing. Only pods can only run for maximum of 30 days until they get rescheduled, and so on and so on. So basically, Kyverno helps you automate a lot of this stuff inside of your environment. And because AI, everything is AI now, there's another tool which is called K8s-GPT. It's also open source. And K8s-GPT is basically either can run as a CLI or as an operator inside of your cluster. And it's constantly checking your cluster and sending the data to an LLM. You can either use it. You can either use local LLMs, which I would prefer because I don't trust any of the. We trust no one. Let's get back to the we trust no one thing. So we don't want to send it out, even though you can anonymize the data and it basically tells you what's wrong inside of your cluster and gives you an idea how to fix this, which is nice. And there are a lot of tools that can basically also help you automate all the stuff inside of the environment. And this is what you should always have to keep in mind, that automation is the key, because you won't get more resources to. You won't hire more people, but your infrastructure that just gets bigger. Which brings us to the last point, what we need, and this is observability. I won't go deep into observability because there are talks just around observability. It basically means that we need an all-time deep insight into our environment at any given time, because the more that we know about our environment, the easier we can find a problem in our environment and basically say like, how can I fix it? The goal there is also to centralize it. And again, AI can take a role there because it makes ugly logs human readable. And with this, the new title was born, which is DevSecOps. And DevSecOps basically just enhances the DevOps thing into the new parts that we just discussed. So this is multiple people. This is not one person. This should never be one person. And we basically go ahead now and say like, okay, we have our layer of defense against any intruder already on the code level, where we have SAST and DAST. We have penetration tests. We have our code review principles that at least you have 4 eyes. We have the same on the ops side. So we have we create threat models. What could be a potential attack vector on our system? We have logs. We have we have an automated patch system, and so on and so on. So this is basically the way how we should go forward. And the main problem that we have, and this is always a problem, this is the problem that humanity had since the beginning. This is the problem that I have at home. It's collaboration and communication, because people need to talk to each other, and we have different people from different areas, and they need to constantly talk to each other, because we need to have the dev guys talking to the ops guys, talking to the security guys, and the matter is not like saying no. The idea is to stop, to say like, stop, okay, let's talk about what are solutions that work together and actually work, and not like empty, yeah, we can't do this because no is not an argument. So we have basically DevOps, DevSecOps, and platform engineering, which in the end is everything together. It's just like an enhancement of how we work together. That's a collaboration, and it's key parts that just enhances the idea of DevOps or SRE or how you ever want to call it. And the good thing is this is evolving, like a lot. The funny thing is we reached DevSec MLOps when we have all of this AI stuff in it. Triceratops we haven't yet reached, so this is we still need to get there, but we will eventually. And that's it. Questions, anyone?
Oh, by the way, we have already one question on top of here. So if you don't use the DevOps as a description, how do you distinguish between operational and company internal process stuff and operational VAT stuff?
I mean, this is a debatable thing, how you use those terms, right? In the end, it's I have operations, I have security, and I have developers, and these are the three roles, and they should go into teams based on where they operate together, because they need to exchange with each other what is going on. And I mean, the distinguishment is you still have those specific roles, right? And how you organize your teams is just an organization topic. Yes. Was this your? Okay, then we do the other one.
Yes, but just I really trust that someone's posting it anonymously, all these questions.
Yeah.
When it comes to the collaboration, who should lead the conversation? Would it happen in the first place?
That's an interesting one. The lead should be the topic of the person that created the requirement, which means the requirement can come either internally, externally, or by a customer. So basically, we would go ahead and say like, a customer we want to run, a department wants to run stuff inside of containers. We don't have a container platform, so we need Kubernetes, for example. So we decided to go for Kubernetes, which means that the operations folks say, okay, we go to the infrastructure folks and say like we need the hardware, and we go to the security folks and we need the requirements for our security team. So basically, they would lead in the internal technical discussion, but the overall process is led by the people that brought in the requirement, and these maybe be a department. They need to push, okay, these departments now need to work in each other. But I would basically go that ops is the one that, at least for the platform part, should go into the lead.
Okay. Here we have a question from the room.
Thank you for the presentation. If you're told that trust no one and everything should be encrypted, what is the gain versus the cost comparative? If I have load balancer before my Kubernetes cluster doing SSL offloading, and inside cluster everything is open, and every service connects to the other service through the inside cluster, to the gateways, to the proxy services, compared to everything is encrypted with tens or hundreds of services inside the cluster.
I mean, the good thing is that you can also encrypt traffic inside of a cluster.
Yes, technically I can. The question is, what is the cost compared to gain?
Oh, that's really easy. If you use, for example, Cilium as CNI, it's the cost is neglectable because it's the encryption happens on the eBPF layer or on the kernel layer, and the overhead is really small. So there are tools that makes this way easier, and they just ship with encryption more or less. So this is basically what we tell most of our customers. If what CNI to choose, yeah, go with Cilium because you have encryption already integrated. It's like a check mark done.
Okay, if we don't have any more questions, thank you for this energetic presentation after the lunch. I see that someone's still somewhere in the lunch mood. But okay, thank you, and big applause to Mr. Mario.
Thank you. Thanks.
Thank you.
Thank you very much.